right, so we are supposed to define Newton's third law, then we'll talk about action and reaction pairs. I'm going to go ahead and title our notes today Newton's third law. How many of you have heard the statement, every action has an equal and opposite reaction? Most of us have. And so that is Newton's third law, and let's kind of digest that just a little bit today. Every action has an equal and opposite reaction. That can get us into trouble sometimes, but we won't quite go there. There are two parts of this. There's two sides of the story. So what are the two parts of this statement? The action and the reaction. Okay. So something has to happen first, and then something happens as a result of that. There's always this is Newton's third law is one that kind of gets into philosophy a little bit. A lot of times you hear people use this as an example for things that are very much not physics. So let's kind of keep that in mind as we think about it to digest it a little bit. But this statement is very true. We have two parts. There's always at least two parts. A single isolated force cannot a single isolated force cannot exist. There's always two parts. It's just like a story. There's always two sides. A single isolated force cannot exist. And that's really important. We've already kind of seen that in some of the things that we've done with when we talked about tension. If I have a light hanging from the ceiling, then that light has a weight, and that light has tension on the rope, on the cord, whatever it's being hung from the ceiling with. Tension equals weight. Okay. We had the example of a book sitting on a desk. That book has a weight, but it also has the normal force that is counteracting that weight so that it doesn't get squished into the table. So the normal force equals weight. We've already kind of seen that in balanced forces that we've talked about. Okay. So let's talk about these two parts, these action and reaction pairs. And that's what you're going to really be asked to do later. But action and reaction pairs. Action and reaction pairs. There's three things that have to be met in order for them to be an action and reaction pair. The first one, the forces are equal in magnitude. The forces are equal in magnitude. The forces are equal in magnitude. So just like we saw with tension and weight and normal force and weight, they are equal in magnitude. The second point is that they are opposite in direction. Opposite in direction. So again, just like with tension and weight, opposite in direction. Normal force and weight, opposite in direction. And then number 3, the forces are on different objects. Okay. So if we look at the examples that we have in the lesson today, we'll kind of go through those and consider. We have this balloon. The air, it rushes out. Okay. The balloon, you just let go of the balloon, is going to go the opposite direction of the air. Right? So the air gushes out, the balloon flies off. How many of you have played pool before? What happens when you strike the yellow ball with the white ball? The yellow ball moves, right? There's a reaction there. So if we look at that example, notice that the force arrows are the same. Okay? So we could put colliding billiards balls. We have the one when they hit, the white ball is going to bounce off, the yellow ball is going to bounce off. We have equal and opposite forces. That white ball doesn't just stop when it hits the yellow ball. It keeps moving. Okay? Think about the rocket launching. So we're going to kind of talk about rockets a little bit later in the year when we talk about projectile motion. But this rocket launching, okay, we can have our rocket, okay. Make sure we have a fin on our rocket. Okay. And then we have the fire, right? So we have the force of the engine versus the movement of the rocket, and those should be the same size. Right? So we'll move on to what about this planet's orbiting? Kinda, yeah. Planets orbiting. The force of gravity on the Earth is the same as the force of gravity on the moon, which we talked about that a little earlier with gravity. So we have Earth, we have the moon, but this force is the same. The Earth is pulling on the moon with its gravity, the moon is pulling on the Earth with its gravity, but the force is equal because they are an action and reaction pair. Okay? All right, so kind of thinking about this idea of pairs. Which one has to happen first? The air gushing out or the balloon flying off? The air gushes out. So there's your action. The balloon flying off is your reaction. Right? Which one happens first? The white ball hits or the yellow ball bounces off? White ball hits. There's your action. And your reaction is the yellow ball bounces off. Okay? So kind of, and then here, like with Earth and the Moon, it's really kind of hard to tell which one is the action and which is the reaction. But in this case, we would usually say that the larger mass was the action and the reaction was the moon's gravitational force there. All right, so let's look at that football video, which is the next thing in our list. So that's all the notes we need to take today.